Hello everyone. In this video we are going to discuss something called measures of variations. Okay. The measures of a variation can be calculated in two different ways. One is called the sample standard deviation, and the other one is called sample variance. They are technically they have the same way of finding these two. However, sample standard deviation is the putting a square root on top of it. So it makes the value a little bit smaller than the variance. Okay. So sample standard deviation, we use the letter S, lowercase s, and the sample variance, we use the S square. Okay, so what is the sample standard deviations? Well, sample standard deviation is a spread of the data from the mean. Okay, so roughly speaking, the average distance of the data from the mean, or it indicates or tells you how wide your data is being spread out from the mean. So let me give you a brief example. Okay, why is the standard deviation so important? Okay, let's assume that we have two different classes. Let's say one is a morning class. Hang on. Okay. So let's say we have a morning class here. And let's say the other one is afternoon. Okay. Let's say we just took the first exam, and we have the x by the sample mean of the class. Let's both the class has 30 students. Okay, same. And I found out that the both classes have the average of 70. I mean, when you look at the these two classes, just looking at the mean, you don't see any differences here. Okay, but let's assume that the morning class, the score of the 30 students are much closer to the 70. For example, like this. Okay, like this. I mean, I cannot put all 30 of them there, but I think I can. Okay, let's say all we have the most students, they all have pretty much the like this. Okay, so in this case, let's assume that S equals 2, standard deviation is equal to 5. But when I compare to the afternoon class, and these red dots are the actual score of each student. Let's assume that those are 30. But afternoon classes are much more distant, like so. Okay, they kind of spread out all over the places. Okay, like so. So I calculate that S equals 2, maybe 15. So by looking at the sample mean alone, x y equals to 70, you don't see this type of informations unless it is given to you, right? So when you look at the graph of the first one, the morning class, most of the student scores are compacted around the mean, right? So that kind of the variations among the scores for those 30 students are very, very small variations. Okay, compared to the afternoon class, even though we have the same number of students and same average, these scores are has a lot larger variations, and kind of they're spread out a little bit compared to the morning classes, right? So this sample standard deviation gives you another dimension of looking at these data Okay, now the morning classes are compacted around the mean, and afternoon classes are much more spread out from the mean. So when you make some kind of a decision based on this type of analysis, standard deviation is going to give you a good idea how the data, given data, is forming around the mean. Okay, so when we're talking about the variations, we have to understand that the variation, okay, among the small standard deviations, it means that your data, the scores of your data are much closer together, and the larger variations, meaning that they are being spread out from one another. Okay. Now, why is this so important? Because you know, the location of these data are going to be very important when we talk about the you know, normal distributions, so you know, correlation and regressions. It comes into the play every time. Okay, so the variation just tells us, okay, the spread of the given data. Now, we're going to have to remember that sample standard deviation and sample variance are simply the same thing, but the sample standard deviation, it was just going to give you the smaller standard value here. Now, how do we find this then? How do we find the sample standard deviation? Now remember, sample standard deviation we use S, but if you use the population standard deviation, we use something else. We'll talk about that later video. So let's just make sure that we are using sample standard deviation, small lowercase letter s. Okay, so if you want to find the actual standard deviation, sample standard deviation, this is going to be our formula. Okay, now remember that when we talk about the sample mean, we also looked at the x sigma, right? So the sigma is simply means add them all up. X is going to be representing the each score, and then we have a mistake here. That should have been x bar here. Okay, I'm going to put bar here. There should be x minus x bar square. And then we're going to have to divide that by n minus 1. If you don't square root, that's going to be sample variance. And if you put square root on top of it, that becomes sample standard deviations. So here's the example here. So we have a small elements in a data set. So we got 1, 2, and 6. So each at 1 to 6 represents the x1, x2, and x3. So here's the x here, 1, 2, 6 there. Then we are going to divide x minus x bar here. So here the x bar is simply, okay, let me just do that here. So you got x bar equals to what? 1 plus 2 plus 6 divided by 3. Okay, so that's just going to be 3 there. So that's what we did here. So x minus x bar. First one was, okay, 2, right? I'm sorry, the 1. Okay, 1 minus 3. And that's how we got negative 2. Then next one was the like 2 minus 3. Then we got 6 minus 3. Okay, so that's how we got minus 2, minus 1, and 3. So then we're going to have to square first. Find the difference between the actual score and the sample mean. Then once we find the difference, then we square them. So you got minus 2 squared, we get 4. Minus 1 squared, we get 1. And 3 squared, we get 9. So we add them all up. That's what the sigma here means for. That's what that means. So we have what? 4 plus 1 plus 9. We get 14. Then n is equal to 3 because then we have a 3 the elements here. So we have 3 minus 1, we get 2. So here 7 is going to be our sample variance. Okay? If you take the square root of the square root of 7, we get 2.6, and that means this is called the sample, okay, and standard deviations. So what does the S equal to 2.6 means? Okay. So what does that mean, 2.6? So we have to understand this. So the average distance from this S equals to 2.6. That's how what the average distance, okay, from the sample mean. Now, if the given distribution is a normal, okay, let's say that we will talk about this later, but if the distribution is a normal, then what the sample standard deviation simply means this. Okay, there are, hang on a second. Now remember that these has to be, if the distribution has to be normal, otherwise this will not work. Okay, so I will show you there, hang on. So what that means here is that the about 68%, for example, let me just here, 68% of all data is going to be lie within 2.6 from the sample mean. Okay, in other words, that let's say the mean is going to be 3 here. So if I draw the picture there, okay, so let's say the x bar equals to 3, then this was a simple example, so we have to be careful here. So 5.6, okay, and the about what, 0.4. Okay, so about 68% of all data is going to be lie between 0.4 and 5.6. Okay, now then 95% is going to be lie between 2 standard deviations. Okay, same kind of thing. So you got 1 standard deviation here. Now you got 2 standard deviations. So we're talking about maybe 11.6. We're talking about now it's going to minus 2.6. So it's pretty much most of the data is going to be falls into this over here. Okay, so there will be a 1 standard deviation, and this will be a 2 standard deviations. So 68% of the data will be within 1 standard deviations, and the 95% of data will be within 2 standard deviations. Okay, then after that it's going to be 99.7% will be within 3 standard deviations. So that pretty much covers all the data, right? So that's kind of give us the idea how this data is going to be located from the mean. Okay, so if the distribution is normal, then we can apply this 68, 95, 99.7% rule and apply it to the given data. Okay, so we'll talk about this more in detail in class, but we will be we'll just have some idea what the sample standard deviation is. In other words, that how do we actually find the measures of variations and understand what the variation means. Okay, all right, we'll see you next time. Okay, and some other topics of statistics. All right, bye.